culture with an emphasis on bees and other beneficial insects. As a principal investigator on the Beneficial Insect Survey Network, which is partly supported by Ducks Unlimited Canada, Paul's team has collected evidence of the abundance and distribution of pollinators and the natural enemies of crop pests throughout Alberta, producing what is likely the largest database that exists for the prairies. He sees great potential in croplands for win-wins, where both habitat conservation and agricultural objectives can be met. He is currently researching the conditions under which prairie farmers may see an actual yield benefit from retaining wetlands and other natural habitats in their fields. And as you can see on the screen, the title of Paul's presentation today is The Buzz About Sloughs, Prairie Wetlands as Hotspots for Bee Biodiversity. Okay, Paul, welcome, and the presentation's yours.
Thanks so much, Dale. If at any point you can't hear me or I fade off, please don't hesitate to let me know. So my initial title for this presentation was Prairie Wetlands as Hotspots for Insect Biodiversity, but I found that as I was preparing it, there was a great deal of bees alone to talk about. So I decided to focus in on the bees, the six-legged bees, as opposed to the eight-legged spiders and harvestmen that we've also collected. So I just want to, before we go further into this, I just want to acknowledge the great number of people who have been involved in some of the work I'm going to present here. In particular, I'd like to acknowledge those people I've underlined in this list. Lincoln Best, who's been a really fabulous bee taxonomist for us. Sarah Johnson and Jess Vikruck, who have led our field and laboratory research program each for 2 years over the last 4. And in particular, highlighting Jim DeVries at Ducks Unlimited Canada, who has actually been a sponsor of this work, a collaborator, and in many ways an inspiration. Gregory Sekulich at Canola Council of Canada has also played an important role in helping us design this work and implement it. And indeed, Ducks Unlimited Canada and Canola Council have funded the large part of what you will see here today. Together, with also significant contributions from Alberta Conservation Association, Alberta Biodiversity Monitoring Institute, and Alberta Innovates, among others. So the question that motivates a lot of what we do is, where are the wild things in the prairie croplands? And if you look at the prairies from space, this is much of what you'll see. The green bit is the forest, the boreal forest largely, and that occupies about 4.2 million square kilometers. But the other bit, and that's about 500,000 square kilometers, is largely a crop rotation footprint. A lot of it is canola. That's the yellow area on your screen. And that is a place of largely intensive agriculture where the wild things might have a hard time persisting. And in particular, that's what we wonder about, is where are those wild things, and are they there in high abundance? Of course, this is very much aligned with Ducks Unlimited objectives to look at their wild things that use this part of the world. But what kinds of wild things, wild places are we looking at? And I like to call them the non-farmed spaces. The most abundant non-farmed space throughout much of the yellow region on that last map are actually road margins. Road margins, thanks to the Dominion Land Survey in the 19th century, laid out a really nice grid across much of the prairies, and the road allowances around those roads provide a nice band of uncultivated, unfarmed, sometimes mowed and sometimes sprayed land that can host and provide habitat, particularly for the small things that we like to look at. Then there's the stream margins and perennial grasslands as two other major kinds of land covers that are unfarmed across that cropland region. And then finally the wetlands, and the one we'll be focusing on mostly today in this talk, the wetlands and the margins around them that are uncultivated and provide a place where particularly the six-legged sort, the bees, might make their home. So what are the benefits of these non-farm spaces? Very generally, a quick overview of what the benefits to people might be of these non-farm spaces. And the big one, the one that we try and discuss with the landowners, is the notion of pest control. And looking at insects in particular, these non-farm spaces might provide a home or a habitat for things like beetles, spiders, harvestmen, also parasitoid wasps that might help control the crop pests. From another view, these non-farm spaces are actually opportunities for conservation, whether that's for pollinators or other insects or indeed other animals in general, because it's an opportunity to reserve habitat out of production. And farmers, of course, are always looking to expand the footprint of their production. In part because it's those non-farm spaces in the middle of fields or on the edges of the fields could be turned into crop, or also they might get in the way of farm equipment. So opportunities for these wild spaces are all across the board, and the big ones on the prairies, of course, are pest control, conservation, and then finally pollination. There's a potential for bees that are hosted by these non-farm spaces that make it their habitat to actually pollinate some of the crops. Canola, alfalfa being two of the ones that we might think about. So looking at the prairies from the spaces between are the interstitial spaces, and the common ones that we might see as we go from east to west across the prairies are road allowances, as I mentioned, but the ones we'll focus on at the bottom left there in southern Alberta are the pothole or depressional wetlands. And looking at that full section on the scale there of each square, there are, some sections can have dozens of these wetlands, and the margins around them potential to provide habitat. Let's look at one of these depressional wetlands and the area around it from a bee's eye perspective. There's 3 bees eyeing it, and what might they see? They might see nesting habitat, this sort of somewhat soggy, depending on wet years, maybe dry. In dry years, nesting habitat for the bees, and many bees in the prairies are ground nesters. There's also potential for nectar and pollen. There are flowering plants here that, of course, provide nectar and pollen, and they have phenologies that continue throughout the season. So this provides a source of food for bees. And what about in the distance? There's the canola crop. Canola crop might not be home for a bee because you're going to find frequent soil disturbance, seed drilling, or if you don't have zero-till, you're going to have frequent tillage that's going to disturb the soil, or maybe insecticides that are going to make it sort of inhospitable for bees, especially for ground nesters. But they might also see that canola field as a short-lived pulse of bee food. Canola flowers in July provide somewhat useful nectar and pollen. And also farmers might see this landscape as a pollen-limited crop, and they might see, in turn, the bees that live at the wetlands as an opportunity to give that crop a yield boost. Today I'm going to wrap the remaining of my comments around a hypothesis that can be stated as follows. Prairie potholed wetlands are wild bee hotspots. We're interested in figuring out whether they're hotspots for bees. And the mechanism, as all hypotheses need some mechanism, is because their margins provide a consistently non-farmed space for nesting. And the margins also provide a habitat for flowers that can provide pollen and nectar for bee food. When you think deeply about this hypothesis, or maybe not so deeply about it, you can come up with 2 predictions that really allow you to kind of test the notion of it being a hotspot. Prediction 1 is, if you look at these wetlands and you move away from them, bee abundance will drop off with distance. That implies that locally within a field, you might have a hotspot. Because bees, you might be using that wetland as a central place, and either for finding food or for having a nest. So as you move away, you're just going to see fewer bees just by the random movements of them. The second prediction is bees will be more abundant and diverse near wetlands than at control sites. So if you look across at a landscape scale, you're going to find if these wetlands are indeed hotspots, you might find more bees and a more diverse community of bees at wetlands and at control sites. So these are 2 kind of implications of the notion of hotspots, and we can test them at a local scale and a landscape scale. And the remaining of the results that I'm going to talk about were generated through our beneficial insects surveillance network between 2015. We've now got funding for that through 2022. And we sampled at a bunch of sites throughout Alberta, as you can see on the left there, from Lethbridge North to Edmonton, the red dots, and the ones with squares or blue circles around them are locations where we sampled in fields adjacent to wetlands. The red spots were we sampled near fields, usually in road allowances. So 332 sites in or near crop fields, 82 of those were in the fields, and 65 were near wetlands, for a total of 9,000 trap weeks of sampling. That's a lot of time in the field with traps waiting to catch these bees. And we caught about 150,000 arthropods through that process. About 112,000 of them are currently curated and identified at the University of Calgary Insect Collection. So for insect networks, this is a pretty large extent and also a pretty large haul as well. So a good data set with which to ask these questions. So this is what it looked like back in the lab. Bees, if you weren't aware of this or not, of course, just the honeybee. We have in Alberta alone well over 300 species of bee, and they can range in shape and color and size dramatically, from the bumblebee at the top left to a green or blue or even orange bee, as you can see in these other pictures. And this is what our lab work looks like, bees arrayed in trays. So this haul pulled in about 307 species of solitary bee, 25 species of bumblebee, the kind that makes a colony, and of course also honeybees, which are placed on the landscape largely by honey producers. So if we look at the question about bee abundance, the prediction, will bee abundance drop off as we move away from a wetland? It turns out we just published this result in Biological Conservation, just recently accepted. It's now in press, and this work was led by a postdoc with my lab, Jess Fickruck, who shepherded this work all the way through from beginning to end. Lincoln Best and Michael Gavin both also did some critical bee identification work, and Jim DeVries from Ducks Unlimited Canada, important collaborator throughout. So this was the prediction in detail. As you move away from that wetland, you're going to see fewer bees, and that in croplands in particular, in canola or cereal. But as a kind of control in perennial grassland where there isn't frequent soil disturbance, you wouldn't expect to see this relationship, because the bees could distribute their nests and indeed their foraging continuously as you move away from the wetland. Whereas in canola and cereal, the tilled fields where the wetlands are kind of like an island in the middle, you'd expect to see a drop-off. And this is how we did it. We visited wetlands and we set up sites distributed at 0, 25, and 75 meters away from the wetlands. That's a quarter section in each case. And you can zoom in and see what that looked like here. So it turns out, and this almost never happens, but it did actually work this way. Our results almost exactly mirrored the predictions. They even had the same colors when we spat them out of the regression. And we found indeed exactly what we predicted, that as you move away from a wetland in a cereal or a canola crop field, the bee abundance does indeed drop off, and it stays pretty flat in a perennial grassland. Another interesting result is that if you look at the grassland sites in particular, you're going to find a different composition or a different assemblage of species. A different set of bee species are hanging out in the grasslands compared to the crop fields. So implying not only does the wetlands provide hotspots, but different types of wetland contexts can host different communities as well. And this all work all comes out of some Bayesian negative binomial multi-level models. So we've got some evidence for our first prediction. At the local scale, we have evidence that bee abundance will drop off as we move away from a wetland. So it's like a local hotspot, an in-field hotspot. But what about at the landscape scale? Are wetlands hotspots in comparison to control sites that are distributed throughout the landscape? So here's how we did that. There's a quarter section again, and we compared our wetland sites to ditch or roadside control sites that were sometimes at the same fields as the wetlands, but also distributed throughout the landscape as a whole. To tell you just the headline here is that no, wetlands were less diverse than ditch sites as a whole. And here's how we figured that out. If we look at the control sites, we had 123 sites, and we found 184 species over 841 trap weeks of sampling. Although wetlands had fewer locations, even though we sampled considerably more at wetlands in total, more effort, and we found fewer bees. So in comparison, at a landscape scale, wetlands are just a subset of what we would find at ditches. But that really makes sense when you think about it. Ditch sites are on roadsides, which are like a transect, and they cross through all sorts of habitat contexts, and they were randomly distributed. So we would expect far more diversity in this case in the background condition. Wetlands, in turn, though, are hosting a large proportion of our total diversity, so we shouldn't discount them entirely. Even though they're not more abundant, they're not hotspots in a sense, they're still providing an important service. And when we look at abundance, we find a similar story. So diversity is one thing, the number of species, but what about abundance? Are wetlands hotspots? Do they host more bees of a given species than the background condition, the ditch sites distributed across the landscape? And I'm going to show you now a series of figures that look like this, and to help you read them, along the x-axis, horizontally, you've got the time of year, the day, so it's like a seasonal index. And then as you go on the y-axis, you've got the abundance of bees. The green lines show ditch sites or the control sites, whereas the blue lines show the wetlands. So if the blue line is above the green line, it means that wetlands have a higher abundance. So in these cases, we have got 3 species of common solitary bees, and they tend to be more abundant in the ditch sites, in the control condition, than they are in the wetlands. Mining bee, Andrina amphibula, Agopostrum texanus, and Duforia mora, all fairly common bees, are more common in this sort of background condition, although we do see them at wetlands. This is all data from zero-inflated Poisson gams. Now, what about specialist bees? Well, there are a few cases of specialist solitary bees specializing on particular flowers that turn out to be more common at wetlands than at ditch sites. The blue line is higher than the red line in these cases, and you can see throughout this, Melisodes rurvalis, a specialist on bull thistle and native prairie thistle, tends to be found more often at wetlands. And these other 2 species, Anthophora occidentalis, specialist on monarda, and Diodasia australis, interestingly, on cactus, is found more frequently at wetland contexts than at ditch contexts. So, pausing for a minute now just to talk about differences among solitary and social bees. Here's a picture of the rear end of a solitary bee doing some digging. Many are ground nesters in Alberta, and they typically do not travel far from their nest. So when we say not very far, they might, if the wetland was in the middle of the field, they probably wouldn't make it to the nearby ditch. Social bees, on the other hand, can get around a lot. They're generally much larger, like this bumblebee, which makes a colony and has a queen, and also honeybees as well. They can travel much greater distances from their colony. So when we look at some social bees in the same kind of context, here's a honeybee, we can get around more. They're not so limited by needing to nest or be near their wetland or wherever they are. So indeed, honeybees, Apis mellifera, tend to move around a lot, and we're seeing pulsing here, which probably implies they're moving around from wetland or to ditch throughout the season based on what flowers tend to be in bloom. These 2 bumblebees, Bombus rufocinctus and centralis, tend to be more common in wetlands, in ditch sites in both cases, and they're both very hyperabundant common bees. Now, but there are other types of bumblebees also quite abundant. Bombus borealis, a very abundant bumblebee, is more common in wetlands throughout the season. Nevadensis, a huge bee. This is a really large Nevada bee. Nevada bumblebee is called, and Turnarius, also at times of the year, are more common in wetlands. So this implies that, first of all, there are species of bumblebee that are responding, probably, we don't know this for sure, probably to pulses of flowers, and also that wetlands provide a key resource to them, at least at some point during the season, if not throughout the season. But there's another bee, and this bee is Bombus occidentalis, the western bumblebee. It was COSEWIC designated in 2014. COSEWIC, of course, is the agency that reports on potential species at risk. And it was listed as threatened. It used to be a hyperabundant bee throughout the prairies, but now it's much less frequent. And we found them much more at wetlands than we did at ditch sites. So this is important. We have a species at risk here. It has been already designated by a federal agency that is actually more abundant at wetlands. So a key resource it could be for this bee, particularly in the Prairie pothole region. But taking it a bit further, there are more bees that have been listed, and we found them. This one actually is species at risk listed by, or SARA as it's called, and federally recognized under the Species at Risk Act as of May 2018. Bombus terricola has legal status in Canada, and we found it slightly more often in wetlands than in ditch sites. Whether or not we found it more often in wetlands or in ditch sites is besides the point. It was using wetlands, and this is a listed species of special concern. So certainly wetlands play an important role, if not a hotspot, for this particular species at risk. But there's more. We actually found 5 specimens of Bombus bohemicus, the gypsy cuckoo bumblebee, excuse me. Cuckoo bumblebee is a kleptoparasite, so it doesn't make its own nest, it relies on the nests of other bumblebees. And it's actually designated endangered under the Species at Risk Act as of May 2018. We actually pulled in 5 specimens, 2 at wetlands and 3 at ditch sites. And indeed, CSIWIC has been very interested in this data, as we actually have one of the largest current collections of this bee anywhere. But what's interesting about Bohemicus is that it is actually a specialist, or a kleptoparasitic specialist, on terricola, which, as you'll note, is also a special concern. So indeed, it's probably declining because its host, terricola, is also in decline. So an interesting story there. So we've got evidence at the local scale, and then the landscape scale. We didn't really find that wetlands were more diverse overall than these controlled ditch sites, but depending on the species and depending on the time of year, certain species of bee could be more abundant at wetlands than they were at these background or control sites. But whether or not they're more or less abundant, whether or not they're hotspots, is probably secondary to the fact that bees are definitely using wetlands, and the communities of the bees surrounding these wetlands are significant subsets of the background landscape. So to summarize, what are the take-home messages? Are Alberta prairie wetlands hotspots for wild bees? At a local scale, at the field scale, they support higher local abundances. So you could call them reservoirs, if you like, of pollinators within crop fields. They also host distinct species assemblages. At the landscape scale, though, they support higher abundances of certain species, not all by any means, depending on the time of year. And we've got some evidence that social bees may relocate to forage on periodic pulses of flowers. So whether or not they're providing nesting habitat, wetlands are probably also providing floral or foraging habitat. And finally, wetlands may be used preferentially by 3 species at risk, 3 bumblebees at risk in Canada, designated or officially listed. So that just about sums things up. So I just want to conclude by encouraging you to contact me if you have any follow-up questions. There's a picture of me. In case you ever see me in the street, you can wave. I also just want to thank Ducks Unlimited and IWWR for inviting me for this, and just acknowledge again Jim DeVries for a considerable amount of support and collaboration throughout this work. And also thanks to Dale and Brian for inviting me.
Okay, well, thanks, Paul, for a very interesting presentation. So